All right, so let's do a bit of set notation in MathML. We'll go over some set definitions of elementary number sets, and we'll go ahead and sort of briefly cover this number line, which I've written in JavaScript using a for loop. And you guys just let me know in the comments if you want me to actually do a sort of full video on how to code up a number line like this. But otherwise, I'll just sort of briefly show it and show you how it sort of integrates with this HTML file. And let's just recall that MathML is an XML dialect. And so MathML is typically an element that is added or included in an HTML file. All right, so let's get started. Okay, and so basically what we have here is just a table setup. So it's just going to be a 2x5 table with all of the content, all of the relevant content fitting inside of those respective rows and columns. All right, so let's go ahead and set up the first definition for the positive integers. So that'll be definition 1. And all I'm doing here is just adding attributive annotation. Again, recall the main purpose of this is really to sort of improve the legibility of the code. It's to flesh out the code stack itself and make it more legible for humans and also for machines as well, more interpretable for machines as well. Okay, so we have our enumerator, definition -1, and then we're going to add in the next data cell a nomenclatural clause. All right, and this class assignment is sort of idiosyncratic or domain specific to the particular CSS file that I have set up here. Okay, so don't worry too much about that. All right, and so we're defining the positive integers. All right, and so let's go ahead and set up the math stack, which is going to include the set definition for the positive integers. Okay, and so all I'm doing here is attributing the type set definition to the positive integers. All right, so we're going to enclose the sort of two standard set theory or set indicators for the positive integers, which of course are also called the natural numbers or the counting numbers. We're just going to embed those indicators inside of a math row element. And again, I've attributed the type set indicators to the semantic field containing two indicators, two indicator symbols, namely the indicator that is typically assigned for the positive integers exclusively in this case. And I'll use the vertical bar as a separator between the two indicators. And the second indicator being a double struct capital N, which stands for the natural numbers. And what I'm including here as annotative attribution are the entity encoding and the character set code points for this particular indicator. Okay, so next we're going to list a math indicator of equals, which in this case, again, is a definitional assignment as opposed to an operator. And for the elements of the set, we're going to continue to use mfenced, again, noting that it is being deprecated in most rendering engines or for most rendering engines, but in a variety of text editors, it still renders perfectly fine. All right, so let's go ahead and set up each of the respective elements, and then, of course, an appended ellipses at the end of the set to indicate the continuation of the counting numbers. Sharp S referring to the semantic field of elements, an instance of 0 factorial, which equals 1. So another synonym for the natural number 1, and unit being a name, a common name for the natural number 1, the natural number 1. Okay, second element, once again, semantic field of synonyms. 2 is an element of the natural numbers, the prime numbers, the integers, the rationals, and the real numbers. And we're going to use the Greek character delta to refer to the notion of divisibility attribute, okay, or divisibility property. And yes, so 2, the number 2, the natural number 2 has a divisibility property or divisibility attribute of even. Okay, the natural number 3, once again, semantic field of element of the set of natural numbers, prime numbers, integers, rationals, and real numbers. And in this case, a divisibility attribute of odd. And finally, we'll conclude the set definition with the horizontal ellipses, which is a syntactic element of punctor. All right, so that term being a hybrid of the terms punctuation and functor. Okay, definition 2. Let's set up the table row. Okay, so next we'll define the notion of 0. Okay, so again, just a list of names here. 0, naught, and null are some common names for the element 0, which is really a set in some sense. From a set theoretic point of view, it's a set onto itself, or a concept anyway, onto itself. Sure, we regard it mathematically as a whole number, which is really a matter of convenience. And of course, you do have some mathematicians which regard it a natural number, a notion that I would disagree with, but the whole numbers as a set are certainly useful. All right, so we have our enumerator. Okay, and we're going to specify in this case, again, for the sake of stack alignment here, that it's an ordered list. Okay, we're enumerating an ordered list. All right, so definition 2. And then in the second column, in the second data cell of this particular row, we'll annotate with definitional nomenclature. All right, once again, the class specification is incidental. All right, and then let's go ahead and indicate the namespace. All right, once again, we have 0, naught, null, origin. Origin is a common term used, particularly in Cartesian coordinate geometry, so in analytic geometry. Okay, so let's set up the math stack. Attributive annotation, set definitions, and once again, the class specification is incidental. And so what I'm doing here is I'm going to allow myself a bit of editorial leeway here, and I'm going to use the symbols for truncation, okay, so truncating, in combination with the double struct capital W to refer to the notion of 0, all right, as a truncated set excluding the natural numbers. So the set of whole numbers is typically a combination of 0 and the natural numbers. And to define 0 in this case, all I'm going to do is use the notion of truncation to sort of eliminate the natural numbers from the set of whole numbers, leaving us just with the notion, the symbol, a sort of contrived symbol for 0. Okay, so this next element in the list is a symbol typically used to mean naught or null, and it is most commonly seen in computer science works or computing and programming works. Okay, and so then just a sort of typical 0, which is universal. That's sort of the universal symbol for 0, and then followed by the sort of, or the symbol for naught or null, which is more commonly seen in mathematics publications, which is again just a 0 or a null or an O even with a diagonal strike through its center. All right, so this next symbol, we're going to go ahead and embed it inside of a math row element, and it is commonly referred to as the empty set, not to be confused with a set containing the empty set, all right, but rather it's a set with no elements, so containing nothing. That would be referred to as the empty set, and we're going to give it a type attribution of parenthetic. We're going to specify it using three math indicators. Namely, an open brace, okay, so a left brace, a phantom data cell, a phantom data entry, and a right brace. Okay, so next we're ready to define the natural numbers. So let's go ahead and set up another row. Okay, inside of that row, again, we're going to have two columns, two data cells. All right, so next we're defining the prime numbers. It says natural numbers there in the attribution for the table row, but let's ignore that for the time being. Come back to that. Definition 3. Once again, a nomenclatural clause. We're going to indicate a noun phrase. All right, and so let's go ahead and set up the math stack. Once again, we're going to attribute the type set definition to the prime numbers. And I'm going to make a few CSS adjustments to the HTML entity, which I've just simply taken from the character viewer catalog here. And I'm just going to sort of adjust the color a little bit. All right, and then once again, we're going to use the definitional assignment of equals as opposed to the operator equals. Okay, nothing is being done in the sort of arithmetic sense to this particular set. Okay, we're just assigning it. Okay, and again, we're going to construct the actual set itself inside of an m-fenced element with open and close braces, separator, comma. One of the sort of easiest ways to write a set without having to use a multitude of math row elements or math row tags. So just a nice and easy, sort of convenient way of doing it. And then we'll include our familiar elements inside of the set. So we'll set up the semantic field for the number 2. All right, so once again, the number 2 is an element of the set of natural numbers, set of prime numbers, the integers, the rational numbers, and the real numbers. And again, we're going to specify using the Greek letter delta to mean divisibility attribute, okay, or divisibility property. So the number 2 has a divisibility property of even. Or another way to think about it is we're assigning the number 2 a divisibility attribute of even. And then for the number 3, the prime number 3, the semantic field is the same except for, of course, the divisibility attribute assigned or inherit is odd. And then, of course, for the prime number 5, the semantic field is pretty much the exact same as that of the prime number 3. All right, looks good. And so we'll conclude this set definition with an ellipses element. Okay, and once again, the ellipses, the horizontal ellipses, is a syntactic element of type puncture. All right, and then last but not least, in this list of definitions, we're going to go ahead and define the negative numbers, the negative integers, rather. All right, definition 4. With an attributive value of enumerator. All right, we'll lead with the noun phrase, the negative integers. We'll go ahead and set up the math stack, and we'll attribute the type set definition to the negative numbers. Okay, and so similarly, to the positive integers, we're going to include an indicator that is prefixed by a superscript of minus in this case, specifying that we're going to be defining the negative integers as opposed to the set of integers in its complete form, which would include the negative integers 0 and the positive integers. So the set of integers is, as a complete set, is a combination of 3 sets, right? But in this case, what we're talking about is, what we're defining is the set of negative integers. All right, so it's a definitional assignment, and we're just going to specify, in this case, that the equals sign, the equals indicator, has an infix form. And just like before, we're going to go ahead and structure the elements of the set inside of an m-fenced element. And of course, the difference here is just we're going to be starting with the ellipses as the first element of the set, indicating the sort of infinitude below zero of the set itself. Okay, so in MathML, the formal way to write a negative number is to construct it inside of a math row element and to list the two characters, namely the minus sign and the value, as separate characters inside of the math row. So let's see how to do that. All right, and so we've attributed the opening tag for the row with an arithmetic expression of type negative number. Okay, and so the minus sign is listed as an operator. It is doing something to the value. The minus sign is a functor, okay, as a type functor, and it is printed in the form prefix, okay, as opposed to a regular operator, as opposed to an infix operator, essentially, which simply spaced differently. So this is just an aspect of typesetting more than anything else. Okay, so there you have it. So we have all of our set definitions. So let's go ahead then and work out, or just include, I suppose, the little number line that I had at the beginning, which is a way of visualizing each of these sets of numbers. Okay, so we'll just set up the graph inside of a div element, and we'll give an attribute of number line on the unit scale. And again, a bit of CSS to optimize the formatting layout for this object. And really, it could also be given inside of a section element, an HTML section, or as an HTML object. It doesn't matter, but in this case, I've simply done it as a div. Probably less standard, but yeah, that's how I went about it. Okay, so we'll need an HTML5 canvas with an ID of, well, in this case, I gave it the ID CVS, and as I said, if folks want to see how I really built this thing, and by all means, I'd be glad to make a quick video on it. All right, and so we just need a script element with a source reference. And there you go. So all it's doing is reading in this particular file by the name of fig1-1.js, which is where I've hosted the JavaScript. Okay, and then just a label for the graph. All right, there you go, figure 1-1. All right, so there you go. So there's everything. Yeah, please let me know what you think. Let me know if you have any questions regarding any of the code or any of the programming choices that have been made here. Right, so I'm just going to go ahead and just quickly show you the JavaScript file so you can at least see it. Okay, so it just kind of looks like this. And yeah, so there you go. So all right, great. So that's pretty much everything. If you have any questions, let me know in the comment section below. If there's anything you want me to cover in particular, I'd be happy to do that. And if you want to see the source files, you can find a link to my GitHub account in the description section below. All right, so yeah, if you like the video, please don't forget to give it a like and go ahead and subscribe. And I'll see you in the next one.